Hi everyone, welcome to my channel. My name is Vahidas, and I'm here to solve some data structure and algorithm questions for you. Hopefully, this will be helpful for you in finding your next job at any kind of tech companies that you guys are looking for. The question that I have picked up for today is a classic one, the question of two-sum on a sorted input array. This question is question number 167 on Leetcode. You can find it on any other similar platforms online. It's a very common and popular questions with different companies, as you can see here. The main difference between this one and the easier problem that we solved before this one is the fact that the input array is now sorted, and we have to solve this problem in constant extra space and in linear time. Now let's take a look at the question prompt. Given a one index array of integers, which is numbers here, that is already sorted in a non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where index 1 and index 2 are between 1 and the maximum length of the numbers, and index 1 is also smaller than index 2. Return these two added by 1 into an integer array of length 2 with this format. Your system must use only constant extra space. All right, let's take a look at the example provided here. It's very similar to the example that was provided for previous question. We have this array 2, 7, 11, and 15, and our target is 9. The output is 1 and 2, simply because if you add up 2 and 7, their sum is 9. Therefore, index 1 and index 2 are the answers. We have another example here, 2, 3, and 4. Target is 6. In this case, the answer is going to be 1 and 3, an array that includes 1 and 3, because the sum of 2 and 4 is 6. So we return these indices. We have example 3 here, and this time it's -1 and 0. The target is -1, and the output is 1 and 2, because they add up to -1. Values with index 1 and 2, they'll add up to be -1. Let's take a look at the constraints. This is the range of the numbers, the range of the values, the length of the array. They're sorted in non-decreasing order, which is going to be very important. And we always have exactly one solution. Awesome. Now, I'm going to bring this up, and let's take a closer look at how we can approach this problem. So if you have 2, 7, 11, and 15, we know that they're sorted in order. So one thing that we can make use of is doing a search. One important thing, I'm not gonna over the brute force approach with time complexity of O(n) square, because that's not gonna be optimal. So one thing that we can make use of is knowing the fact that these are sorted, so we can go over each element of the array, for example 2 here, and then let's see if target minus numbers I actually exist in this array. So we can search for that, and we can use binary search for that. So if we use binary search, we can find this element, and that would be our answer. This is one solution that comes to mind. The thing with the solution would be that although our memory will still be O of 1, which is what the question required. So this is our space complexity. Our time complexity would be n O of n log n. And why is that? It's because We have to go through all the elements of the array, and then we need to find the complement, this value, and see if this exists in the array. And this takes log of n in terms of time complexity. Let's write down and implement this solution and see how it goes. Maybe we can find a better solution after this. Awesome. So we're going to go over all the elements in the array, and I'm going to use the Kotlin's features. So we're going to go over both the indexes and the values. And for using that, we're going to use with index function on the int array. And now we need to calculate and see if I2 actually exists. So let me call this I1, and now I'm going to search for I2. Numbers, binary search, and we need to find for target minus value. We know that when we're searching for the complement of this value at this index, we don't have to search. Our search does not need to include this one, this item. So we can search for the items after that. So knowing that, and knowing that we're going over a loop, at each point, for example, if I'm here, let's say here, and I'm looking for the other answer, I've already have searched for the complements of these two, so I don't need to sub my search in the array from this index or this index. I can sub the search from this index all the way till the end. So I don't need to include these two. So I can provide a start here with this function. So I will say that you need to start from I+1 index. Awesome. Now, to make sure that Kotlin has found an answer, you have to make sure that this is bigger than 0. Because what happens is if it doesn't find the value that we're looking for in a search, it's going to return us the location where that element needs to be in a negative format. So if that element is not contained in the array, it's going to return the inverted insertion point. So that will be minus insertion point minus 1. Basically, we just need to make sure that this is bigger than 0. In this case, we're going to return an int array of I1 plus 1, because the question asked. This is what the question required. And I2 plus 1. By this point, if we have not found the element, we can throw an exception. The answer is not found. Let's run this and see if we have any kind of errors. We're missing one parenthesis here. Okay. Okay, I don't need this, and I don't need this. This should work now. Awesome. All test case were accepted. Let's submit this. Amazing. And our solution was accepted. But we can easily even see here that its time complexity is not very good. And as I pointed earlier, this would be of O(n) log n. But is there any way we can improve this? One of the techniques that we always can use for questions like this, let's start all over again, 2, 7, 11, and 15, is to use 2 pointers. So simply, we will go around the array using 2 pointers. And we know that all the elements here are sorted in a non-decreasing order. So I start P from the beginning and Q from the very end. I can do a calculation of their sum at each point. And 2 plus 15 would be 17. And the target that I'm looking for is 9. And intuitively, we can see that 17 is bigger than 9. Now, I know that my array elements are sorted. In order to get closer to the correct answer, I need to reduce the sum. And the fastest way to do that is to decrease Q index by 1. Now, Q is pointing to 11. So if I calculate the sum, 2 plus 11, it's going to be 13. Now, is this bigger or smaller than 9? It's still bigger than 9. So I need to reduce the sum. So I'm going to decrease Q, decrement it by 1. And now Q is at index 1 with value 7. 2 plus 7 is going to be 9. And we have found an answer. Perfect. This approach would work perfectly. And if we, for example, would have started from this point to in Q, and let's say our sum would have been 7, we know that 7 is smaller than Q than target, which is 9. So in that case, we needed to increment P and move P one element until we find the solution that we are looking for, which is sum of the values at index P and Q would be equal to target. All right, knowing this, let's modify this solution and let's use a different approach. Actually, we don't even need this for loop. I'm going to use P and Q. P would be at index 0 and Q would be at the size of the array, minus 1. And this would be numbers. Now I'm going to use a while loop, and you can see that P is increasing and Q is decreasing. So we should keep doing this until they're equal. So as long as P is smaller than Q, we can go through this while loop. Now I'm going to calculate their sum at each point. So their sum would be the value at index P and the value at index Q. Now, the first thing we're going to check is whether our sum is equal to target. In that case, we're simply going to return the answer, which is an interarray of P plus 1 and Q plus 1. Now, otherwise, there will be two scenarios. If the sum is smaller than the target, then we need to increment P. Otherwise, we need to decrement Q. If sum is smaller than target, decrement Q. Otherwise, if sum is bigger than target. Otherwise, increment P. I think everything looks good. Let's give this a chance. All right, it looked great for the 3 test cases that we have here, and let's try submitting it. Awesome, our submission worked perfectly, and its time complexity already looks better than the previous submission, which is 15%. So main difference, the main benefit here is that our time complexity here is O of n, because simply we're going through the elements of the array, and we're not using any extra data structure. So our memory complexity remains constant. Well, thank you very much for following this. I'm looking forward to see you guys in our next videos. If you liked and enjoyed this one, don't forget to subscribe and like our videos, and feel free to post any comments, any questions that you may have. Cheers. Bye.